I wanted to create a quick second video to give my recommendations above what the Montclair School Board said they plan to do in the schools or are doing in the schools. The last video, the long video, was more of an analysis and a critique of what they're doing and the limitations. So this is meant to be more solutions based, and the solution is essentially more outdoor air, fresh air, makeup air. If it's going through a mechanical system, it's called makeup air, which is just air from outside coming in. And what I'll show you is, this is something I just received today, put out by an engineer that works for this HVAC company. These are recommendations specifically for schools. So here you've got 1, 2, 3, 4 in order: increase outdoor air ventilation, filter indoor air, which the schools say they're doing with their portable units, supplement with mobile air cleaners, which is again those portable EnviroCleanse units, and then verify ventilation performance. This is something I spoke of yesterday. Verifying performance means once you set up a system and have protocols, meaning the system's operated a certain way in a certain amount of time, etc., someone has to come in and check to make sure it's actually working. One of my HVAC contractors that I work with, who's an engineer, recently went into a school system in a different town. I won't name the town. And they had 40 ventilation fans, and 38 ventilation fans didn't work, and they presumably haven't been working for years. Some of them were not even connected. Some of them had belts missing. Some of them, the motors were disconnected. So these are situations that happen. So even if you had 40 ventilation fans, if 38 don't work, then you're not ventilating the building. And they didn't know that until this engineer went in and inspected the facility. As part of this document, they reference a Harvard study which shows a classroom should have 100 CFM, cubic feet a minute of air, fresh air, for every 250 square feet of occupied space, assuming that 750 square foot classroom area that I mentioned in the other video. These EnviroCleanse units wouldn't be adequate. The EnviroCleanse UV unit, because I own this unit and I'm familiar with it, on high it's 250 CFM flow. That would presumably handle a classroom that's 625 square feet if it's on high. However, on high is pretty loud. It's possible a teacher's not going to want to leave it on high because it's too loud and she won't be able to teach the kids, or they may not be able to hear her, especially with remote video happening. It may be too high and they may lower it. So you already have a problem there. You're reducing the efficiency and the capacity of this filter. If you're relying on this to filter the air in the classroom and it's not on high, you're now filtering less air. So there's potential for more contamination in the air if someone's sick with whatever the airborne contaminant is. This talks about, it's just kind of reiterating what I said yesterday, filters with a MERV 17 are referred to as HEPA. So if the school's using a MERV 13 where they do have duct work, it's not really filtering the small stuff that we're worried about. The small stuff, meaning particles down to this 0.01 micron, which I'll just show you quickly. We're worried about COVID. That's our issue right now. And COVID, here's an interesting little visual that shows the size. This is, I'll try to hold it closer. This is dust, 10 microns, which we're not worried about. Fog, if you could think of how small fog must be. Cement dust, which is also a problem in construction. You wear filters, N95 masks to filter out stuff like that. This is the diameter of a human hair. Here is COVID at 0.125 microns. It's tiny. You can see that it's very, very small. It's going to be harder to filter. You need very high efficiency filters, which means efficiency means you're capturing more things that flow through it. After that, we want to introduce as much fresh air as possible because we're not going to capture all of it. And this just shows again what that graph showed, that it's 0.125 microns. Quickly going over to, this is a CDC document talking about considerations for schools with HVAC. Well, it's with a bunch of things, HVAC being one of them. Use fans to increase the effectiveness of open windows, because like what I said yesterday, on the other video, windows don't necessarily bring in fresh air. They may be exhausting classroom air. And these are things that I didn't mention, I didn't think of. Ensure restroom exhaust fans are functional. If there are exhaust fans, they should be on because you want to suck air out of a closed space. A restroom is a relatively closed space. It's not a huge area. And people are in and out of it, and they're going to the bathroom and they're generating airborne aerosols, and when they wash their hands, water vapors coming off their hands. It introduces a lot of things. So exhaust fans in the bathroom should be on. Use HEPA, as I discussed in the other video. Generate clean to less clean air movement by reevaluating positioning of supply and exhaust. This is what I mentioned in the other video, where just because you open windows somewhere doesn't mean you're getting fresh air into that space. You may actually be pulling air from another part of the building, like the hallway or a bigger room that has more pressure. You may actually be pulling that air in, so you have to be pretty aware, and that's up to the engineers to figure that out if they're doing a great job. And then UVC, which they're already doing. So my recommendation, if I were doing this for Montclair schools, you'd probably still use the filters. They already purchased them. You'd add MERV filters. I would not use the ion generator, the ionizer. I don't think they're healthy generally. I would put UV lamps in all the ducts that they have in the schools. So wherever there's a duct, put UV lamps in front of the filter system. That's the best place you could put it. That kills coronavirus, COVID, it kills rhinovirus, it kills bacteria, other antigens that may be floating around in the air that we're not so concerned about right now. So for the classrooms, what I would recommend is called an energy recovery ventilator or heat recovery ventilator. What this does, this is a small unit. It's like the size of a small suitcase. I have these in my house. I have these in my buildings. We use these everywhere. What this does, it sucks air out. And so if this was in the classroom, this would suck air through this port. It would blow it outside, and then it would suck an equal amount of air from outside, fresh air, and blow it inside. And it blows through this, which is called a recovery core. What happens is, as this dirty air is going out, it takes the heat from the air. So let's use the winter as an example. It's 30 degrees out, but the classroom is 70. 70-degree air goes outside, and when the 30-degree air is coming in, it picks up the heat energy from this air, and it transfers it to the air coming in without actually crossing the air paths. These air paths go through a core. It's almost like straws that are crisscrossed. So you don't get the contamination from the air going out, but you get the heat from it. So the air coming in, instead of coming in at 30 degrees, as it is outside, it tempers it, and it may come in at 55 degrees or 60 degrees because they're very efficient. This is what I would put in every single classroom. This would make me feel comfortable about sending my kids back to school, because you can't filter all the air in the classroom, as I mentioned in the other video. You would need much more filtration and much more air movement to be able to continuously filter the air, because remember that the air is filtered over time. So the filtration over time improves the air quality, but as people are in the classroom and using it, there's kids breathing and teachers, and aerosols are being generated. You're continually dirtying the air, essentially. So you're trying to keep up with that filtration. And as I just showed you, the EnviroCleanse doesn't have the capacity to filter that much air where you're really pulling everything out of the air. So if someone's got COVID and they're in the classroom, those COVID aerosols are going to be in the classroom and other people are going to be breathing them. It's just inevitable. It's the matter of fact. The more fresh air you can blow in there, the better the air is going to be. This is better than a filter. It's better than UV. It's better than everything else. This is trying to basically simulate closer to an outdoor environment. So you want to pump in as much fresh air as possible. This goes through a small filter, but we're just going to bring it as much outdoor as possible and get the classroom air as close as possible to the outdoor air, because the outdoor is safer. And this is just an example. These are different size units. Some of them are oriented one way or another way. These get little 6-inch ducts. They get hose attached to them or a diffuser attached to them, depending on how they want to put them in. And these are the same price, typically, as that EnviroCleanse unit, portable unit. An EnviroCleanse portable unit is about $800. These are in the range of $800 or $1,000, and they would go out a window. You put a duct, it would go out a window, it would suck fresh air in, and you use this year round. It doesn't matter if it's 5 degrees outside or 85 degrees, this is going to temper the air and make the air more comfortable. And there's other units, I just pulled these off of the internet, I Googled ERV to get some pictures. This is a through the wall or through the window unit that doesn't require ducting. But there's a lot of options, and I just wanted to make people aware of what an energy recovery ventilator is, or sometimes they're called heat recovery ventilators. That's my recommendation. I think that's the way you get the air very clean, safest way you could possibly go back inside. So it's something to think about, and something you may want to talk to your school about, or the school board or facilities people, and see if they would consider implementing these.